Flying. When you think of the word, planes, birds, insects, and bats most likely come to mind. But there are some wackier animals that take to soaring in the skies, from frogs to squid, and today we'll be taking a look at some of those wackier flying animals. So first up is an arboreal fascinating flying frog. Yes, an arboreal and flying frog. Wallace's flying frog, named after Alfred R Wallace, who collected the first known specimen, who was also a socialist. What has that to do with this vibrant video? Well, don't worry. These frogs are endemic to Southeast Asia, end meaning within, endemic meaning population, coming from the word demos, which means people. This specific frog is in the family of Rhacophorus, which includes a number of other flying frogs. However, we'll be focusing on this one. It has large weighty webs between its sizable toe pads. Large toe pads. Try to remember this. Also, do you know that 45 degrees is the best angle to launch at if you want to get the furthest range? In 90 degrees, of course, the least, which means frogs in general can adjust this jump angle to see the distance they can reach. I assume they innately just judge these angles, though I don't know. I'm not a frog neuroscientist. The frog spends most of its time during the day sleeping sagaciously and resting, then at night it gets active, just like me, looking for food and mates when applicable. Literally me. They spend most of their time in the trees gliding to get around, looking usually for, of course, food, in this case insects and small invertebrates, and avoiding prowling predators. And when it is mating season, they come down at night with the female laying eggs and the male fertilizing them. Yay! Reproduction. They have enlarged toe pads as mentioned up there, if you still remember you're a reliable guy, which can spread out the force of landing on trees. Surface area is a fun, functional thing, dispersing the force like Wallace wanted the labor to be. The flaps of skin and webs between their toes help when they glide from tree to tree. The flaps act as a small parachute, making their daring descent slower. Like on an aside, your skin has a large surface area. It weighs more than 15% of your body weight. So if you weigh like 60 kilograms, that's 9 kilograms of skin. Now, have you ever thought about how squid swim? I mean, fish have swim bladders, comment if you want a video on that, and fins, but squids have a fin and arms, so how do they get around? Next up is the soaring cephalopod, which can help us answer that and more. The Japanese flying squid is a squid that, as you can see in the name, can be found in the northern Pacific Ocean, the area around Japan, some of China's coasts up to Russia. They can live up to 1 year and die after mating, like salmon. Comment if you want to see a video on animals that are fated to die after they lose their virginity. I'm still alive. The interesting thing is that they fly. So how do they fly? Through a jet propulsion system. They can glide up to 30 meters. They suck up water and push it out, so like a high pressure water gun. They spread out their arms and soar through the air, unsurprisingly increasing surface area through their arms, of course. Surface area is a fun thing. This is usually how squid get around too, besides of course launching themselves out of the water. They suck up water and push it out, so like a pump. Another thing is that their soft bodies mean it is hard to find squid fossils compared to things with harder bones, which is something that they share with sharks. Now, why is it hard to find shark fossils? Well, there are two main types of fish, bony and cartilaginous. Bones made of cartilage, bony being those with bony skeletons and cartilaginous with cartilagey skeletons. A shark is cartilaginous, for example. The only part made of bone is their teeth, which also means that the part of them that can easily be fossilized is their teeth, not the rest of their skeletons. An example for a bony fish would be the common carp. If sharks could fly, that would be crazy, but imagine if snakes could fly. What if they actually can? Well, in the phylum Chordata, because snakes are shaped like cords, we find the freaking flying snake. This is kind of a nightmare scenario. I mean, imagine walking down a forest knowing that a snake could just land on you at any moment. They are insane, found mainly in South Asia. There's a number of species of these, but we're just going to generalize here. They're kind of cool because, well, they don't have wings or any flaps, but they manage to glide large distances. So kind of like a gliding tube. Undulation is the action of moving up and down or back and forth. Now these snakes move by aerial undulation. This helps them stay upright and not tumble over to the right, left or any side. Basically, it's kind of like a dance, moving around to create lift and drag. This is essentially limbless flight or limbless gliding. Now, the physics of this is so complex that I don't want you to ask me for a video of this. But however, they do have some loose skin and they kind of flatten out, which again increases the surface area.